Good day, good day, good day. How are you all doing? This might be a little bit different, a little bit weird. You might not expect to see this here. However, I was asked to help by quite a few of my students explain square roots and some exponential laws, just dealing with how we apply them and some little tricks in terms of mathematics. So here we are. So first of all, I want to start off just by explaining a square root and what exactly a root is, a square root or a cube root, whatever the case might be. So first of all, we take for granted that we use this root and we sort of use it however we want and we find our answer. But how will we actually express this if we're trying to express this without using a cube root? We've got to realize that all the math that we do has to come from somewhere. We don't just do magic, we do mathematics, right? So when we are solving, let's look at this through an example. First of all, let me take the square root of a common number that we all sort of know, most of us know, the square root of 25, okay? And the square root's really asking us what number times by itself twice will give us 25, right? That's the question it's asking us. But how do we express that mathematically? So I know, and if you don't know, that's also okay. You can put inside of your calculator, the square root of 25 is equal to 5. Okay? So we know that the square root of 25 is equal to 5. But how do we get from year to year mathematically? So the first thing we need to realize is that we can express 25 in different terms. And an important part of mathematics is learning how to express things in different ways, looking at their fractions and their notations, and trying to figure out how we can express that in a way that is easier to manage. So in this case, I want to look at this more in terms of my final answer. So what I'm going to do is I'm going to factorize this in terms of prime factors. Okay, so if I factorize 25 in terms of prime factors, that's going to become 5 squared, okay, equals 5. And now we've expressed it like this. Therefore, I can see that if I can get rid of this 2, I end up with 5, and remember there's an imaginary 1 here, 5 to the power of 1. So to get rid of this 2, I've got to think about what operations I could apply here to turn it into 1 at least. So I can minus 1 from here, but that's not a consistent rule. Remember, this root sign represents a consistent relationship between the square of its number and the root of its number. And we need to try and express that relationship. So if we are dealing with 5 times 5, which gives us 25, we might be tempted to say 25 divided by 5, which we certainly can, but that's not going to give us a rule every single time. As we go up and up and up, like if we deal with cube roots, if we deal with quad roots, that rule's not going to be consistent. So you want something a little bit more consistent than that. So what we do, the other way that we can turn 2 into 1, okay, is by simply dividing it by 2. So that's all a square root does. A square root divides an exponent by 2. So 5 to the power of 2 divided by 2 equals 5. Okay, and that's basically what our answer is. So we can say that a square root, if we want to represent that in different terms, can be said to be equal to x to the 1 over 2. Okay, and we can apply this in a few other ways as well. If we go cube root, and let's say it's x to the, let's erase this, we don't mean to say, erase this, we don't mean to say that it's minus 3. Let's say it's x to the power of 5, and we want to cube this out, or we can actually make it x to the power of 6, just so we can have a nice round number. What I can do is I can express this as x to the power of 6, and you just take the number on the outside and divide it by 2. And that's important. A lot of us don't think about the fact, but there is actually an imaginary 2 on the outside of this root, hence why it's called a square root. It cancels out a squaring of a number. Okay, and this goes a little bit into the fundamentals of mathematics, which I'll get into in another video about inverse operations and how we nullify operations. Okay, hope that makes sense. If it doesn't, please leave a comment, a message below, asking me to explain that, and I'll try and make another video to follow up and explain it. Secondly, what we also need to realize is we can look at some exponential laws as well. So let's go on from here and let's chat about some exponential laws. Okay, the first one I'm going to talk about is probably not obvious. I'm not saying at the beginning here. I'm assuming that most of you have seen exponents before, and you just really need some help just upping your game a little bit. Here's another common one that I've seen before. If I have 1 over x, okay, a lot of people don't know that you can express 1 over x as x to the power of minus 1. Okay, so when we are trying to move this into the denominator, or sorry, from the denominator into the numerator, we can simply put it to the power of a negative number. So if I have 1 over 2, and I just don't want this to be in the denominator, I can express this as 2 to the minus 1. And there are a number of reasons as to why we might not want it in the denominator, but that's not super important as for now. Just realize that it's something that we can do. Okay, so let's look at this now again. So in another example, we have y, okay, over x, and let's say for some reason I want to swap these over. What I can do is I can then write it as x to the minus 1 over y to the minus 1. Okay, let's hope that that is helpful. Secondly, some of the exponential laws. I think a lot of us are aware, or a lot of people who are watching the video are aware, but if you're not, when you're multiplying exponents, okay, you simply add their exponential values. Okay, why do we do that? We'll get into that in a second, but we're going to go x to the power of 1 times by x to the power of 3. The answer is x to the power of 4. Okay, now this is not the same as this. And this is really what I want to talk about here. I will focus on some fundamental exponential stuff if you guys need it, if you guys ask for it. But as of right now, I just want to look at this because this is important. Okay, so this is not the same as this. This is the answer to this is actually x to the power of 3. Okay, and why does it work out that way? Well, it works out that way because the rule is that we multiply whatever is on the outside with whatever is on the inside. Okay, so if I have x to the power of 1, like I do here, you could also express it as x times by x times by x, right? Because that's what this means. This is x cubed. It means x times by x times by x. So we're multiplying everything inside of this bracket, x times by x times by x, over and over again, and we know that this is 1, 1, 1, and according to this rule here, we're going to add our exponents. So we go, whenever we're multiplying, we add our exponents, so it's 1 plus 1 plus 1. Okay, now let's look at that again. If we break that up into something else here, let's say we have another example. Let's use a different color. I like to shake things up a little bit. Okay, so let's say we have x to the power of 3 and y to the power of 2. Okay, times by, let's not make it too much, times by 3. Okay, there are two ways that we can express this rule. Firstly, I can just quickly do it. I can go 3 times by 3, which becomes x to the power of 9. Okay, and I can go 3 times by 2, which becomes y to the power of 6. Okay, and it's actually a good idea to not do it like this. You're going to see now what it's actually a better idea to do, and the reason why it's a better idea is because you're going to make less mistakes if you actually open these brackets up, because this is going to help you with separate terms. So if I have something like this and I go x3 y to the 2, this simply means that I must write this bracket out 3 times. So I'm going to do that. x3, y2, x3, let me just scroll over, x3, y2. Okay, and if I multiply this out now, it's going to become 3 plus 3 plus 3, which is going to become x to the power of 9, and this is going to become 2 plus 2 plus 2, which is going to be y to the power of 6. Okay, I hope that that makes sense. Now, why would we not want to simply just do the quicker method? This is quite tedious, and we don't really need it, right? We know the rule. But the reason why I recommend that we do the longer method is because what ultimately happens is you're going to eventually get something like this: x minus 2 squared. Okay, and what inevitably happens is that most students will go 2 times by the exponent of x, which is x squared, which is going to be minus the exponent of 2 here, which is going to be 2 squared. And maybe they're when thinking about it, they're like, okay, this is minus minus, so they put it like this, and they're like, okay, cool, and they try and figure it out, and they say that minus 2 is going to become plus, so they go x squared plus 4, and they're feeling really great about themselves because they thought about this, and they're like, yeah, I got it. Okay, but if we take the longer route, okay, which we know is going to be accurate, I instead write this out as x minus 2 times x minus 2. And what happens is I now have x times by x, which becomes x squared. I then have x times by minus 2, which becomes minus 2x. I then have minus 2 times by x, which becomes minus 2x. And then I have minus 2 times by minus 2, which becomes plus 4. And this is then going to simplify, and I get x squared minus 4x plus 4. Okay, and we can see that these are two very different answers, and we want to be careful. This is correct, this is not. Okay, so it's good to get into the habit. That's just my little crash course. I hope that that helps you out somewhat. If you have any questions, please let me know. I'm going to try and release one of these every week. Next week, I'm thinking that I'm probably going to look at those inverse function stuff I was talking about, sort of like an introduction to algebra, a little crash course in that, and how we think about numbers. Yeah, let me know if you need any more help, and I'm very happy to go through some more sort of example type stuff. Just don't have a lot of time this evening. I hope that this is helpful to whoever is watching it. So thanks so much.